Determine all intervals of concave up or concave down and determine the coordinates of all inflection points, including cliffs, for the function f of x equals x to the fourth minus 8x cubed plus 24x squared minus 8x minus 10. The first thing to do is find the domain. F of x equals x to the fourth minus 8x cubed plus 24x squared minus 8x minus 10 is a polynomial, and the domain of a polynomial is all real numbers, or negative infinity to positive infinity. The next thing to do is find out critical numbers. We will need the second derivative. We will start with the first derivative. F prime of x equals, the first term is power rule, bring down the power, subtract 1 from it. Second term is power rule, bring down the power, multiply with the negative 8, subtract 1 from it. Third term is power rule, bring down the power, multiply with the positive 24, subtract 1 from it. Fourth term is a constant times x, derivative will be the constant. The fifth term is a constant with no x, derivative will be 0. We can now find the second derivative. First term is power rule, bring down the power, multiply with the positive 4, subtract 1 from it. Second term is power rule, bring down the power, multiply with the negative 24, subtract 1 from it. Third term is a constant times x, derivative will be the constant. Fourth term is a constant with no x, derivative is 0. We will want to fully factor the second derivative. There is a common factor of 12. Factoring that out will leave behind x squared minus 4x plus 4, a trinomial quadratic that can maybe further factor into x and x. We need two numbers that multiply to be a positive 4 and add to be a negative 4. Negative 2 and negative 2 will take care of this. Since they match, we can multiply the two factors together and write as x minus 2 quantity squared. We can now set the numerator equal to 0 and the denominator, if there is one, also equal to 0, and solve for all x's. Because of the x minus 2 factor, x equals positive 2. The fact that it's squared just means that the x equals positive 2 is repeated twice. We now check to see whether this is in the domain. The domain is all real numbers. X equals 2 is a real number. It's in the domain. It is therefore a candidate number. It is a candidate to be a possible inflection point. We can now draw a domain line, a line representing the domain. It has no left end because it starts at negative infinity, and it has no right end because it ends at positive infinity. We can put all candidate numbers on here. We have x equals 2 is the only candidate number. This splits the domain interval into two separate intervals. We can pick a test value in each of the intervals. The first interval is negative infinity to positive 2. 0 is in that interval. The next interval is positive 2 to positive infinity. 10 is in that interval. We can now test the concavity by plugging the test values into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version. That is this one here. Now, a couple things about this. The 12 is a positive, and the x minus 2 is quantity squared. And a quantity squared is always positive unless what's inside is 0, but what's inside is only 0 at the candidate number of x equals 2, and that's not part of the intervals here. So that x minus 2 quantity squared will be positive. The 12 is positive. When we multiply positive times positive, it is positive, so this entire second derivative is positive for all test values. That means we will have a positive second derivative in this interval corresponding to concave up. We will have a positive second derivative in this interval corresponding to concave up. So we have concave up happening from negative infinity to positive 2, and then union, because it's happening again, from positive 2 to positive infinity. Those intervals cannot be put together because the 2 is not included. It's round brackets on the 2, because the 2 is the candidate number. Right at the candidate number, of x equals 2, the concavity is not changing. In order to have an inflection point, the concavity has to change, and it's not changing here. And therefore, x equals 2 is not an inflection point, and x equals 2 is the only candidate number to be an inflection point. Therefore, there are no inflection points. So we have two intervals of concave up, and we have no inflection points.